Okay, so now we are at question 2. So a plane is given by the equation 3x minus y plus 2z equal to 7. So we need to determine whether the point P lies on the plane. Okay, so what we can do is actually we can substitute the coordinate of P into x, y, and z and see whether it will be equal to 7 or not. Okay, so that's what we're gonna do. So we have 3x minus y plus 2z equal to 7. Sorry, we're gonna substitute first. So 3 multiplied with 2 minus 1 plus 2 multiplied with 3. Okay, so we have 6 minus 1 plus 6. So we have 11, which not equal to 7. Okay, so we're gonna conclude that since 11 is not equal to 7, meaning that the point P does not lie on the plane. Okay, lie on the plane. Okay, alright, so we have 2 marks. So the first mark is for this, substitute the point into our equation of plane, and the last one would be this one, the conclusion that you made for this question. Okay, so let's move on to part B. So we have to show that the plane is not parallel to the line. Okay, so if our line is parallel to the plane, this is how it's gonna look like. So we know that on the plane we're gonna have normal vector. Okay, we have n, and for the line we're gonna have direction vector v. So what we're gonna prove is, what we're gonna show is, we're gonna show that they are not perpendicular to each other, meaning that we're gonna use dot product. Okay, so we're gonna use the dot product. So for the v direction vector, we're gonna get it from here because we have r equal to a plus t v. So this is our v, negative 2i plus j minus k. And then for our n, we're gonna read it from here, which is 3, negative 1, 2. So equal to 3i minus j plus 2k. Okay, so we're gonna dot product the two of them. Okay, we're gonna show that they are not perpendicular, since we are going to prove that the line is not parallel to the plane. Okay, so we have negative 2, 1, negative 1, and we're gonna dot with 3, negative 1, 2. Okay, so we have negative 6 minus 1 minus 2, which give us negative 9, and it is not equal to 0. Okay, so don't forget to make your conclusion. So since the dot product is not 0, so the plane is actually not parallel to the line. Parallel to the line. Okay. Excuse me. Okay, so we have 3 marks for this question. So the first one is use the dot product and you have the correct v and n. And the second mark would be here, you do the dot product, the operation is correct and you get the final answer correct. And the last one, make sure you write the conclusion. Okay, so that's how you get 3 marks for this question. Okay, so for the last part, find the angle between the plane and the vector c. Okay, so let's say this is our vector c and this is our normal vector from the plane. Okay, so we're gonna need to find this angle actually. So we are going to find this angle, theta. Okay, so first let's find the angle between the vector c and n first. So we're gonna find the beta first. Okay, so beta is actually equal to the shift cos n dot with c and divided by the magnitude of vector n multiply the magnitude of vector c. Okay, so we're gonna find all the information needed. So first let's find n dot c first. So our n is 3, negative 1, 2. And then we're gonna dot it with c. Our c is 1, 2, negative 2. So we're gonna have 3 minus 2 minus 4, which gives us negative 3. And then for magnitude n, we have 3 square plus negative 1 square plus 2 square. So we'll get the square root of 14. And for our magnitude of vector c, we're gonna have 1 square plus 2 square plus negative 2 square. Don't forget your square root. So this will give us cert 9, which is 3. Okay, so now let's find our beta. So beta is equal to shift cos. So dot product is negative 3, and then the magnitude is 14. Multiply with 3. Okay, so make sure your calculator is in degree mode. So we can have 105.55 degree. Okay, so we're not done yet because we get the beta. We just get the beta. So now we have to find the theta. Okay, so since our beta is greater than 90, so our theta will equal to the beta minus 90. Okay, so 105.5 degree minus 90 degree will give us 15.5 degree. Okay, so that's our final answer. That's the degree between the vector c and also our plane. Okay, so we have 4 marks. So the first marks is actually over here. Okay, you can find the correct dot product and the magnitude of n and c, and then this will be second mark, the correct beta, and use the correct formula to find the theta will give you the third mark, and last one is your theta. Okay, so that's how you get 4 marks for this question. Okay, that's it from me. Bye bye.